Alrighty, the next presentation is about to begin. Alright, this one's a big one, so I'll do it in two parts. I don't think you want me sitting through over 80 slides in one session, but we'll see how the time goes. So this module is on network management. So what we're going to talk about is using our tools such as the Cisco Discovery Protocol, link discovery. So basically these two protocols can be used to map out topology. Then we'll look at the network time protocol. Then we'll look at the simple network management protocol. We'll look at Syslog, how it's used to keep everything together. And then we'll follow that up with how to back up and restore operating system configuration files, and even protecting and managing those files. So let's start off with Cisco Discovery Protocol. Now, this is a Cisco proprietary protocol, works at layer 2, and allows you to discover information about a neighbor that is also a Cisco device. All right, so it only works with Cisco devices, and it works at layer 2. So routers, switches, even some access servers and things like that, anything that runs a Cisco operating system will respond to the Cisco Discovery Protocol. The devices send a periodic advertisement to connected devices that share information about the device, so they get to know their neighbors. Now, it's a very complex protocol. You know, if you want to know about your neighbors, you use the show CDP command and then hit the question mark, and it'll tell you all the options that you've got available to you. The most common one is show CDP neighbor, and then neighbor details if you want more information such as layer 3 information. So this is on by default. Now, you may have reasons for turning it off. So you put no CDP enable on the interface, and that stops the advertisements being sent from that interface, such as an interface facing your service provider, because you don't want to advertise your devices to the outside world. It makes it easier for hackers. And obviously the reverse of that command is CDP enable to turn them back on. All right, so to do this on a global scale across the entire device, in global config mode, you type in no CDP run to turn it off, and CDP run to enable it again. So what do you normally get from the output of the show CDP neighbors? Well, as we can see here from the example output, you'll get the device's name, the local interface used to connect to it, the timer that's been between the updates, its capabilities. So it is a switch, and it's a WAN switch 3560. And its local port is a fast Ethernet 05. Now, if we put the detail command on the end of that, we now get the IP address and a more expanded view of the platform. Tells us a 24 port platform. Okay, so we basically get the same information in a slightly different format, but we now have the IP address of that device as well. So get used to using the command via the packet tracer activity. Next is the link layer discovery protocol. This is a vendor neutral, in other words, industry standard way of building that topology map. These two protocols are what you use to map your topology if your predecessor didn't do any documentation. So this is how you discover what is in your network when there's no documentation, by using these two protocols. So this basically works the same way in that it sends out information on ports, but you've got to, configure it. So you go to the interface after turning it on by the global command LLDP run, because by default we have CDP running, and we go to the interface that we want to find out what's connected to it, and we tell our DP to transmit and to receive on that interface. Then we can use the show LLDP command to find out what's there. So at the moment, it's just telling us it's active and advertisements are sent every 30 seconds. Hold down timer is 120 seconds. And we have a reinitialization to occur. So again, using the neighbors command, it'll tell us what the device name is, the local interface, the hold down timer countdown, what the neighbor's capability is, and what the local interface that we connect to on that device. And it even has a detail option, just like CDP. So again, we can get all that information from the neighbors command, plus we now get the chassis ID and a little bit more details about what's going on. So there's another packet tracer activity for you to use CDP and LLDP to discover your network. Next, we move on to time services. So every device has a clock built into it, and we need to set the time and date manually. All right. So if we don't, all right, so we can either manually configure it on every device and hope that it's close enough. Now, the reason we want accurate times and dates on our devices is for our log files. Because when an activity happens on a device and we have our logging enabled, those event logs get time stamped. So unless we have accurate timing across the entire network, we can't accurately track what's going on. It's critical for tracing hackers and unauthorized activity across the board. Now, we can use the network time protocol to synchronize all of our clocks for us across the network. This is a preferred method because it keeps everything in line, and as we add more devices, it just keeps everything synchronized in against the master device. So we can synchronize and keep all of our clock settings in line, because it doesn't take much to miss a device and just turn it on and it'll default to the clock setting that's in the BIOS, which could be years out of date, and you would not be able to use the logs generated by that device in any way to prove behavior that was adverse to the company. So NTP uses UDP port 123, and if you really like boring stuff, you can read RSC 1305, tells you all about NTP. But basically the way it works is we need to synchronize against a server or a master clock, and then as we step away from the master clock, additional time is added in based on the transit times between the clock and the adjoining devices. These steps are known as stratum levels. So as you go one step away from the stratum, you add one to it. So the authority is the clock, the original source, and NTP synchronizes its information as it moves down through the stratum levels and has a maximum hop count of 15. Anything above 15, it's an unsynchronized device. So stratum 0 is the authoritative source, and it is a high precision timekeeping device. Then we have the devices that are directly connected to it, which are stratum 1. Then we step down through the various servers that are connected to that. They could be other stratum devices or clients, and they use NTP packets from the upper device to synchronize themselves. So stratum 2 devices can act as servers for stratum 3 devices, and so on as you move down. So to view what your clock setting is, you can use the show clock command from the privilege mode, and this will give you the time and date. UTC is the universal time zone. You can manually set time zones if you so desire. But basically what you can do is configure your device to use a NTP server. You've just got to configure it to go off and find it, so you need to give it an IP address. And then what it'll do is it'll change the clock settings after synchronization, and it'll change the source from user configuration to NTP. So it's now in a sync mode with a source. Now, to verify what's going on, you can use the show NTP associations command, and this will list all the devices that it is associated with. And it'll tell you its address, what its source clock is. So it's syncing with a GPS clock. And if you use the show NTP status, it will tell you this device is synchronized with a stratum X. In this case, it's stratum 2 device, and tells you what the IP address of the device is, and then its frequency and precision. Now, you can synchronize other devices in your network back to that router. So basically you use your router that connects to your ISP as your own NTP server, effectively. So all the rest of your network references back to that router, and they become a stratum X+1 device. It's the same command structure, so you'd go in and configure NTP server, and then you point it to the address of the router. If router 1 was a stratum 2 device, then the switch is going to become a stratum 3. Rinse and repeat with another packet tracer activity. Simple network management protocol. This one is used so that we can manage various nodes and get messages on status sent back. So we have a manager and agents and a management information base. So these three elements create the system that's used to communicate between devices. So SNMP is the protocol that we use to manage the devices, and it runs on UDP port 161 and port 162. Okay, so the agents are 161, the manager is 162. So how does it work? We have all the agents, in other words, all the devices we want to keep track of run as an agent. And the device that is keeping track of all of these things are the SNMP manager. So this is where that manager information base resides, and it will send out get and set statements, and they will respond with the trap information back. So how do we work out what type of message is being sent? Well, we get a get request which retrieves specific values or variables. Get next request retrieves a value from a variable within the table. We don't need to know the exact name. It's just a sequential search that will step through the table. Get bulk request allows us to extract bulk, in other words, multiple rows of the table, but we need version 2 or later of SNMP for this to work on. Then we get response, which are the replies to the request, next reset, set request. So set request stores the value of the variable. So it's just a series, it's like a database. All right, we're retrieving information to add it to a table and then looking at the entries into the table. That's all what we're doing. So basically, we want to find out where the variable is, because each variable will represent a different function. So in this case, we're getting the variable to find out whether a particular interface is up. So the status. So we send a GET request. Okay, and it sends us back the values that are in the variable. Traps are unsolicited messages. So these are when changes occur that reset the value in the table, and the network management software can then send a message to the administrator in form of a text message, pop-up window, whatever the software is designed to respond with. We currently have 3 versions of SNMP. So we have version 1, which we started off with, and version 2, which was covered under RSC's 1901 to 1908, and then version 3, which uses these little things called authentication, usernames and passwords, and it also uses hashing and encryption, so it's much more secure. So people cannot intercept these messages and tamper with them, as we have authentication. What's the other one? Authorization and auditing. All right, so we have community strings, which are in use in version 2. These are used to authenticate against the objects, and we have 2. One that can only read the information, or one that can read and write. So only the read-write can change information remotely. The object ID is the name of the variable, and is basically used to identify what's going on from within the information base. Now, some variables are common public variables. In other words, they're covered under RSC. Other ones are specific to vendors, but there's a lot of scope in the RFC for new variables to be assigned to specific things. So we can look at the structure and find out how it's put together. So Cisco is way down on the list here. Okay, so we've got the ISO, it's an org, it's part of the DoD, created the internet, it's private, it's an enterprise, and the enterprise name is Cisco. So its IDs start with 136.141.9. Then it breaks off into the sub-variables. So when we can manually type out a get, if you wanted to, you can. So it's SNMP get, then we type in the version, and the authentication is going to be C for community, and then we need to specify the address, the ID of the variable that we want to get, and then we should get a reply with the variable value. So generally speaking, it's not something you're going to do just randomly, but you can if you want to. And Cisco has a nice little system that documents it for you. So it comes up with a nice little GUI that allows you to translate all these objects and gives you the codes and what they mean. Nice little description. So the lab in this one is for you to research monitoring tools, Syslog. Okay, this is a piece of kit that runs on UDP port 514, and it receives messages and records them on a Syslog server. So when something changes, an event, it sends a message. So we tell the devices, based on its event log, what level triggers a message. So we can gather logging information to monitor and troubleshoot devices within our network. We can specify which of these message types we want to log and record. And we specify where we're going to send these captured messages to for storage. Now, under the Syslog protocol, sends messages under certain conditions. Now, these messages and outputs from the debug are sent to the local logging process on the device. Now, the problem with this is if we lose the device, we've lost the record of what was going on that device because it's not backed up externally. So we really want to record those messages somewhere else. All right. We can view them on the local machine. It's all there. They basically reside in the buffer, and we can get them projected to the console line or the remote terminal, or we can send them to a Syslog server. Now, most networks are set up to send them to the Syslog server because we want one central place where we can go and find these records. Now, we have multiple levels for the trigger points. So we have emergency alerts, critical errors, warning notifications, debugging. Okay, so the lower the level, the greater the importance. So we can categorize what the trigger point is based on those levels. So anything above, say level 4, gets a message sent to the Syslog server, something like that. We can specify how we report it via IP, OSPF protocol, IPsec, interface IP. All right, so we control how the reporting behaves. There's a default template for the way the messages are displayed and structured. So we have the facility, the severity, the mnemonic, and the description. So if a switch ether channel went down, for example, it's a link, it's a level 3, and it's a change from up to down, and it was interface port channel 1, and it changed state to up. So the facility is the link, severity is 3, and the mnemonic was up down. So it's a change in status of the link. By default, these log messages are not time-stamped. We should timestamp so that we can keep track of what's going on when it happened. So when we want to send them to a Syslog server for storage, we need to timestamp the message so that when we're reviewing what's going on, we can have the date and time of the event at our fingertips to understand the sequence of events. This is important for legal reasons and for troubleshooting, because what happens is we can see the sequence of events that led up to a failure. Each vendor will have its own operating system files systems. Most commonly is, Linux. Okay, everybody's pretty confident with Linux. Cisco was originally based on the Unix operating system, which has evolved and is maintained as Linux these days and is now open source. So we know how we can navigate through this file system. So a show file systems command will list all the available files within the device. It'll tell us what flags it has, so whether it's read-write, write-only, read-only, whatever it happens to be. And then we have a clear list of all these lovely little prefixes that we can use to be able to get there. The asterisk indicates the current default file system in use, which is a boot flash/flash, so it's the disk. So if we do a directory command, it will list us all the files that are there. Way down the bottom, you'll get to see this lovely little file called ISR4200 universal K9. And it ends in a .bin. That's our actual operating system. So if we want to change folders, CD, change directory, and then we specify the directory that we want to go to. Notice the prompts change. So the same commands can be used between routers and switches and most Cisco devices that run Cisco IOSs. We can get our logs to be generated into a text file. Alright. And we can use this method to record and save things like our running configuration and startup configuration to a remote location. Alright, so we go into the log, set up the file name for the log file, and then we do the command that displays what we want to capture, and then we can close the logging window, and that will have a config file saved. Now, word of warning, doing it this way, every time you hit the spacebar to continue between page pauses, those pause commands are recorded in your log file. So you need to go in and edit those out. The more common way of saving your config files is by doing a show run and then going back to the start, highlighting the output in its total and copying and pasting. Okay, so in the newer devices, we have the buffers that can do this. In the older devices, we didn't have big buffers for copying and pasting files, so doing it via the logging method was the only way we could capture large files. And there's the more statement that you need to go back and edit out, because if you paste that config file back into the device, if it's failed for some reason, that more statement will cause no end of trouble to your config, as in it'll not actually set it up properly. Okay, you can actually use a TFTP server to copy it to. So basically you have to have your TFTP server running, and the command you enter is copy running config to TFTP. So copy from to, and then it will prompt you for the IP address of where the TFTP server is. It'll prompt you for the name of the file to be saved under, and then you hit enter to do the save. Rinse and repeat the other way. So we're copying from the TFTP server to the running config to restore a config to the device. And it basically will go through the same steps, asking you where the TFTP server is, the name of the file you want to copy down, and confirm to proceed. As technology has improved, we now have USP features in the newer devices. So we don't have to rely on internal storage all the time. We can actually use USB flash as a secondary storage or an additional boot device. Now, these ports will vary depending on the model and form factor. There is no difference in the command structures for copying to and from these devices. The commands are still copy from to. Okay, so where are we copying, what we're copying? So in this case, we're copying from the running config. And where are we copying it to? We're copying it to the USB flash port 0. And then we have to specify the file name and confirm that we want to copy it. So the only thing we're changing is the destination. We can verify it with the directory command to see and confirm the file was copied across. And strangely enough, rinse and repeat with the source and destination reversed, and you'd be able to restore from the USB to the actual device. Now, password recovery is a tricky one. Generally speaking, what happens is it wipes the device. So you need physical access to the device to do this password recovery. And basically what it means is you got to reboot the machine and not call up the config file. Because once you call the config file, all your passwords and everything are valid. Because they're all stored in that file. So we need to go in, break into it as part of the boot sequence. So we need to enter ROMMON mode. We need to change the configuration register, which tells it how and where to find its files. We then manually copy the startup config file into the running config. Now, when we enter that copy command, we're already in the privileged user level. We can then manually go in and change the passwords. Well, we're not really changing the passwords per se, we're overriding the passwords. We still don't know what the password was. We're just inserting a new one. We then save this new running config file with our new passwords into the old startup config, overriding the passwords. Now, before you reload the device, you really should change the config register again back to its normal mode. Okay, just as I would, yeah, just a minor suggestion. So when we turn on, we need to initiate a break sequence from the console. This aborts the normal boot sequence and drops it in the ROMMON mode. Now that number represents the line that will change as you work through. So we need to change the config register, and we do that with confreg and then the hex value that we want to change it to. So 0x means the number is in hexadecimal 2142, which tells the device to ignore the startup config file during the startup process. You hit reset and the device will continue to boot. Now, it's booted up without a config, so it's going to ask you whether you want to enter one, So you go in, get in the privilege mode because there's no config, no passwords. Copy startup config, the running config, override yes, and then we go into global configuration and redo all the passwords that we want to reset. We then change the config register back to 0x2102, then save our running config to our startup config. Okay, now the reason we do a reboot here is to force the change back to the boot being in 2102. Is it absolutely necessary to do a reboot? No. The thing will run fine without it. Packet tracer activity for you to use a TFTP server to back up and reset. Now, normally I prefer to do this lab with a PC running Terraterm. I've got a little file server that it's basically a light TFTP server. I carry those files around with me in a thumb drive. They're that big. You just set up a PC in the lab, run the software on it, and lo and behold, that becomes your TFTP server. So you can back up and save files to it, copy files down. It's a good little lab. And then not all devices follow the same password recovery procedure. Switches are very different. Okay. We're doing reasonably well for time. We might actually finish it all off on this run through. You can watch the videos on your own time. They're in the online curriculum. All right, so Why would we want to use TFTP servers as backup locations? Well, it's a central location, and as it's a server, we tend to back up servers. All right, so not only are the devices having their config files and their operating systems backed up to a remote location so that they're protected, we also tend to back up our servers and take them off-site. So we've always got a backup of our operating systems and our config files for our devices. This allows us to keep control of everything neatly, and if something gets corrupted or accidentally erased, which I assure you can happen easily, we can always access that TFTP server and push out the files that we need to the device. And as I said, I normally carry a little TFTP app in my USB flash drive that allows me to set up and push my personal copies of config files and that out, or if it's in the college lab, I also have a copy of the iOSs for all of the devices backed up, so I can quickly recover the lab equipment if something goes wrong. So if we're going to use TFTP server to back up to, well, first thing we need to do is make sure we can communicate with the server. So we ping it, make sure we've got connectivity. Then we need to verify the size of the file we want to copy, and we do that with the show flash command, and this will tell us the size of the file, and that way we can confirm whether the server has enough space on it or not. Copy the image to the TFTP server. So again, you're using the same copy command from the source to the destination. So we're copying from flash 01 and then the file name. And guess what? We can cut and paste because we just did a show flash. So we now can copy and paste the image file name from that output into our copy command. Makes life so much easier. And then the file will start to transfer over to the server. How do we restore it? It's very hard. Copy TFTP to flash. You'll then ask us where the TFTP server is, what the file name we want to copy. Do we want to change the file name when we copy it to the device? And then it starts copying over the file. And you'll get this series of exclamation marks appear as the copy progresses along. Now, if for some reason we're doing it as a recovery, we may need to do things a lot differently. All right. But we can also specify where this operating system resides. So the command boot system, we tell the device where to find its operating system. So we can specify boot system flash 0, and then the specific file that we wish it to use. Because if there's more than one file in the flash drive, it will select which ones it's going to load. It may not be the one you want. So if you have multiple files on your flash drive, specify where it is. We can also specify that it pulls it directly from the TFTP server, right here, right now. Instead of pointing it to the flash, we can point it to the TFTP server, just to make things interesting. Another packet tracer activity for you to do. So there's quite a few packet tracer activities to do in this module, and a few corresponding lab exercises. But in summary, what did we look at? We looked at the layer 2 protocols that enable us to build a topology of an unknown network. One was a proprietary protocol from Cisco, being Cisco Discovery Protocol. And then we looked at link layer discovery protocol, which is basically, they say, vendor neutral, i.e. industry standard. And these two protocols basically work the same, but CDP is enabled by default on Cisco devices. If you wish to use LLDP, you need to turn it on and enable the interfaces to send and receive the messages. They both will give you information on their neighbour's operating version of their iOS, their IP address, and the device's capability. Now, the only thing that is different is neighbours and neighbours detail. So to get that IP address, you need to use the detail sub command to get the IP version address out of it. Both protocols basically do the same thing. So I'm not going to individually go through them. Next, we talked about why it's important to synchronize our clocks through our devices in our network. And we said you can do it manually, not the preferred method. Next one is we can actually set them up to be referenced to a dedicated time clock using the NTP protocol. And these will sync to a high precision timekeeping device. And then as they move further away from that device, they're known as stratum levels, which are basically hops away. So this allows us to synchronize up to 15 devices away from the source or the authority of that timestamp. We use the command NTP server and type in the address of the device we're syncing against. And what we tend to do is have our router syncing to an external server, hopefully at a 2 or 3 stratum level. As I said, you can have up to 15, but what you want to then do is have your devices in your network sync back to the router so that your entire network is only 2 steps below the one you're syncing against. To verify whether it's working correctly, you use the show clock command, and that will tell you how the clock value is being set. And if you want to get more details, you can use the show NTP associations and status commands to see how it's associated and how it's running. We then looked at the importance of having a central management protocol that keeps track of all the statuses of our devices in the network So any changes in link status and that are triggered, and a central management application will notify the network administrator that something's changed. And we looked at the various versions of that protocol and how the features of it have changed over the years. We looked at how we can research the object unique identifiers that the managed objects database use. So if we want to go hunting for a particular status, we can look it up with a manual get statement if we're so motivated. We looked at the importance of having these messages or status changes recorded and sent to an external Syslog server, and by having all of our devices synced time-wise, we can then use that not just for monitoring of our network health, but for troubleshooting. So we can look at the history in the log files and see the cascading events that led to a failure. So there's that. And there's all different types of facilities and trigger points that we can use to have that happen. We talked about the fact that in Cisco land, the messages follow a strict template, and that we actually have to tell the device to send the message with a timestamp to the server. All right, because the default is it doesn't timestamp the messages. It just gives you the message locally on the device. But really, we need to get it a timestamp and send it for archiving. We then looked at the various operating systems, file systems, so that we can look at how we can back up our device configuration files and even our device's operating system. And we looked at how we can capture it remotely. I proposed an alternative to using the log using Teratome. We can then save files to a TFTP server or a USB drive and load them from those locations as well. I also went through and explained the reason why we want to use these servers remote. The fact that we're backing up these files from individual devices to a central location, then that can be automatically backed up, so everything is protected in multiple locations and can be restored in case of a disaster. And we had a quick look at the boot system command so that we can actually specify directly where our operating system is loaded from and specify the exact version of the file that we want to load. This comes in handy when we've got multiple files stored in the same location. And that brings us to the end, which I powered through. That was 80 slides inside an hour. You must have all fallen asleep by now. All right, that's the end of this one. As you saw, there's a couple of videos to watch in the online curriculum while you're reading. There's lots of activities, both in Packet Tracer and labs for you to do. Some of it requires you to go out and search different sources of information to hunt down different ways of recovering passwords and that. As I said, switches are very much different to routers in their recovery procedure. Again, you need physical access, and it's painful because a switch only reboots by you pulling the power, which can be entertaining if done correctly, or downright dangerous if not done correctly. All right, so be careful if you have to do it.